Lab 6, Alum Synthesis. For this lab, we are going to need aluminum, filter paper. For the aluminum, we are going to need it to be measured out to 0.5 grams, or we're going to act like it's 0.5 grams exactly, and the filter paper will be 0.26 grams. The mass of the alum at the end is going to be, the actual mass is 10.75 grams of alum. From here, we are going to need to take this aluminum, which has already been cleaned and scratched with sandpaper. Going to measure it out, or weigh it out. 0.5 grams, we will add it to our beaker and add our potassium hydroxide. The amount of potassium hydroxide that we added was 4 moles. We will mix this together. This should cause a reaction that should bubble and steam until it is all the aluminum is dissolved into a black substance, which is alum. After this, we will filter out the alum and all the insolubles using this filter paper. As it drains, then we will add the sulfuric acid. This sulfuric acid should be added very carefully. This should cause the crystallization. The amount of sulfuric acid that was added was 6 moles. After this, we will add it to the hot plate. All the insolubles in the alum should dissolve with the hot plate. After 15 to 20 minutes, we will want it to let it cool to room temperature. After a few minutes of waiting for it to cool to room temperature, we will add it to our ice bath. From there, we will add 10 milliliters of this 50-50 ethanol water solvent. This will purify the alum crystals. It should be white and fluffy and at the end. To calculate the theoretical yield, we will take the 0.5 grams of aluminum. 1 mole of aluminum is 26.98 grams. Since there was 2 moles of aluminum, there should be 2 moles of alum and the outcome. 1 mole of alum is 474.46 grams of alum. And the theoretical yield will come out to 8.79 grams of alum. To get the percent yield, we will take the theoretical yield and divide the actual yield right here by the theoretical yield and multiply it by 100. From there, we should get 1.2229 or 122.29%.